What's up, guys? On today's episode of the Good Vibes Garage, we're going to be talking ERV installation and indoor air quality. So what is an ERV and the benefits of an ERV? ERV stands for Energy Recovery Ventilator. So that's an energy efficient way to increase the ventilation and fresh airflow inside your house. So if you monitor indoor air quality, those devices usually look at things like CO2, which is created by humans and pets breathing, volatile organic compounds, which are usually made by cooking or cleaning products, or if you have a fireplace, and things like radon, which are gases that come from the soil beneath your house. So what an ERV does is try and dilute those bad compounds and elements and things like that by instead bringing in more fresh outdoor air, which doesn't contain a lot of those, which can build up inside your house. Now, when it comes to the construction of your home, actually, houses that are more energy efficient and more tightly sealed usually have worse indoor air quality simply because they do not get as much outdoor air or have air exchanges, which is a way you can think about, okay, how frequently, if I were to measure the volume of all the air inside my home, how frequently is all that air changed over with fresh air? And so if you've got a spray foamed house, that's not very frequent. However, if you got a house made in the 1900s, you may be essentially what's called passively ventilated, where there's enough leaks where you can get enough fresh air that can reduce those things. So for my case, I've got a pretty energy efficient house built in 2008, and I was starting to begin to monitor some of these things, and I noticed the more people I would have over in my house, things like CO2 would increase and take a long time until it would get back down to normal levels. And increased CO2 can, sometimes lead to sleepiness or grogginess or things like that. And if you don't have a great number of air exchanges per hour, you can run into those situations where you make dinner and you walk in the house, 6 or 8 hours later, and you smelled what you cooked for dinner. So this video, I'm going to kind of just go over, how to install an ERV, some design considerations, and then show you guys what my install looks like. Before we get into that, just want to go over the mechanics behind the ERV. I've got pulled up here the ERV I decided to install and its efficiency of heat transfer. Now, how an ERV works is all ERVs have 4 duct connections. Those connections are, one of the connections is return air, where it pulls air from inside your house. That air is ran through a cross-flow enthalpic heat exchanger. And so that return air, like I said, exchanges its heat with outdoor air that you bring in from the outside. And so in the summertime, it pre-cools your air as it comes in. In the wintertime, it preheats that air before you then transfer that fresh air, which is now supply air, into your house. And then that return air, once the heat is exchanged with the outdoor air, is then exhausted. So you've got an inlet coming in from the outside of your house, you've got an outlet, and then you've got that return air, and then you have that new fresh supply air now. And so what that does is, for a residential heat exchanger, residential ERV, that efficiency is around 60%. And so that recovers both sensible and latent heat. So you're moving diagonally on the psychrometric chart. On the next slide, I've got how you can decide whether you want an HRV, which just does sensible heat, or an ERV, which does sensible and latent. So that's essentially recovers some energy from both your temperature and humidity of the air. So an ERV, you could, if you wanted great indoor air quality, you could keep your windows open all year. But in the climate I live in, at least in Michigan, the summers are hot and humid, and the winters are cold and dry, and you would waste an exorbitant amount of energy if you kept your windows open all year. Now, if you live in San Diego and you can open your windows a lot, an ERV probably isn't as necessary, but through monitoring, you can kind of tell whether you need it or not. And you know, some areas are more diligent in mandating these kind of things. I think Canada, where your windows are closed a lot, some areas of Canada mandate these in new construction. So yeah, that's definitely some of the benefits they can provide. So like all things, monitor, you know, before you install one of these things or have someone install it for you. Do I have a problem? Do I have an indoor air quality problem? Indoor air quality monitors are relatively inexpensive. They're only about $200. And so you can monitor these things over a few months and decide, or you know, maybe you just think it's a cool project and want to do it. You're always free to do that as well. Um, but yeah, so what I did before I did this, you know, I monitored it for a couple months, and you know, kind of think this was a fun project as well. So I decided to put it in. Probably not as bad of indoor air quality as there exists in some home, but the improvements I'll show later here, it is really cool, really awesome of a device. And man, when you get home, your house just smells awesome and fresh. So for that aspect alone, I think it's definitely worth it to do. Like I was mentioning, you know, that should say ERV or HRV. There's a lot of videos out there and some guides you can find online. A lot depends on your geographic location because that will define what your climate's like. But as a pretty simple rule of thumb, if you have hot, humid summers and cold, dry winters, you should probably go ERV so you can recover the maximum amount of energy. And then you know, plan out the implementation. Do you want to install it yourself? I estimate here about $2,000. When I added up all the Supply House and Home Depot and Lowe's receipts, it was about $1,750. But I threw in 2,000 as maybe a little bit of an overestimate in case you needed some of the tools that I already had. Or I got a few quotes to do this, and contractors wanted close to $4,000. So you know, in the grand scheme of things, I might argue this is one of the best values per dollar home improvements you could do. I mean, $2,000 is like a cheap set of patio furniture when you know, that only gets used sometimes, and this is a device that will really improve your indoor air quality for you and your family. So getting into design considerations, this is a top-down view of my basement and the system I decided to implement. So starting off in the corner here I just got a new furnace installed, so I wanted to get that squared away before I installed the ERV. I ended up getting a carrier furnace, it's got 2 stages of heating and 1 stage of cooling, and then it's got a variable speed fan, so I can also run just a fan-only recirc mode on low. So I've got the airflow of all 3 modes up here in the top right, and that information. And then this down here is my ERV. So before we get into that, how most homes where builders at least kind of tried to provide you some outdoor air, if you look on the return side of your furnace, you've probably got about a 4-inch flex duct that, you know, is probably snaked all through the basement. It kind of makes its way to an inlet, a louver on the side of your wall. And for my case, they put that louver, but then they built a deck over it, so I was getting almost no airflow. But even if there isn't a deck in the way of your outdoor air inlet, you know, when you calculate the pressure drop on that 4-inch flex without, you know, there's no fan or anything in line here, you're just relying on the suction side of your blower, you probably aren't getting a lot of outdoor air if you measure that as a function of total air going through your furnace blower. So I took out this 4-inch flex duct that was my passive ventilation and capped that on both the return duct and the outlet as well. And instead, I'm going to be going and using this ERV. And so, like I showed you, this design is for if you have an existing furnace that you want to tie into for the ERV. So if you've got, like let's say you built a new barn dominium and you've got radiant floors for your heating and you don't need cooling, you just install the ERV standalone. But since I've got a already existing furnace, I wanted to tie into that and use that ductwork so I didn't have to run extra ductwork or things like that. So as you can see, on the far end of your return duct where the air is just starting to come in and go back to your furnace and then get recirculated, you tap in that return duct and duct it to the ERV. And then so in your heat exchanger that's inside the ERV, your outdoor air then comes in, and that energy from the return air is transferred to the outdoor air, and then so your supply air is now preconditioned for before it goes into the furnace, so you don't have to use either your heating coil of your furnace if you're in heating or your cooling coil if you're in cooling. And then that return air, once that energy is extracted from it, is exhausted. So all my duct runs are 5-inch flex, and I also put a damper on this supply side. If I ever had to unplug the ERV and close that damper, then the furnace wouldn't be pulling unconditioned outdoor air through the ERV if the ERV was ever off and I had to make repairs or wanted to take it out or something like that. So when I show you this design, I can go into balancing it as well and the importance of balancing it, but what I found is on my system with the dampers half closed, I'm getting about 50 cubic feet per minute when the ERV is on, and then with the dampers full open, I'm getting about 100 cubic feet per minute, right, 100 cubic feet going that way, 100 cubic feet per minute going this way. So I'll talk about the importance of balancing, but one design criteria to keep in mind, you want to try and keep this side, the runs on this side, equal length to the runs of this side. That makes balancing it easier, and you can keep the dampers roughly in the same positions. If you have vastly different vastly different lengths for your runs on the exhausting side versus the outdoor air side, you may just run into a little bit more difficulty balancing it because those two dampers are going to have to be in unique positions. So I also purposely have it set up this way such that if I set the dampers at the exact same position, because the supply side is closer to the furnace blower, the supply side is always going to be bringing in a little more air than the exhaust side. So I'm going to kind of have it naturally always slightly positively pressurized, and we'll go into some of the benefits of that, but you want to be as close to equal airflow as possible. So now let's talk, probably my least favorite part of this job was doing the controls. So I chose Fantech because I really like their manuals. Their manuals contain a lot of good information, a lot of good diagrams, and I came to learn their customer service is pretty good as well. So I do have a Fantech radon fan I like and installed, and that's kind of what led me to choose them for the ERV. Like I looked at Panasonic's manuals, and they were in like broken English. Braun is a really good brand, but it was really complicated. They had like ERVs that balance themselves, and I kind of wanted to pick the simplest one so I could be in control of the controls and the balancing and know what was happening. And with some of those other ones, I wasn't quite sure if that was going to be the case. So to start off on the right here with the wiring diagram they provided, I looked and said, okay, cool. They sent forth pretty straightforward instructions of how to interlock the ERV in the furnace. So I thought when it was interlocked, that would mean when the furnace fan turned on, the ERV turned on as well. But it was actually the opposite. I guess I should have known that looking at the wiring, but I didn't realize what was happening until I installed it like this and went, oh crap. The only thing that's that's happening is when I turn on the ERV, it turns on the furnace fan. And so why I didn't like that is because you can run into 3 operating conditions, 2 of them being bad and only 1 of them being good. So if you have this set up such that the ERV turns on the furnace only, that's great when they're both running, but you've got 2 other problems. So if the ERV runs without the furnace and the ERV is running and just your furnace fan is circulating that supply air coming from the ERV, you should know that the supply air coming from the ERV is never going to be quite conditioned up to the temperature of the exhaust air because it's not 100% efficient heat transfer. So what that could mean is, let's say in the middle of winter and it's, 32 Fahrenheit or below out, you've got your 32F air comes in and you got 70-degree indoor air. That 32-degree air isn't going to be warmed up all the way to 70 degrees. So it could be discharged in here at 60 degrees, and all of a sudden you're recirculating that because your furnace isn't on, because they're not tied together quite yet. And then all of a sudden you've got, you get a chill in the room because you're actually cooling in the middle of winter. So that's not great. And second thing that could happen is if your ERV is off and your furnace is on, and you don't install this motorized damper that Fantech does call out as their solution to this, if you don't have that motorized damper there and your furnace comes on and your ERV's not on, your furnace could be pulling unconditioned 32 Fahrenheit air in, and really your heating element would struggle to keep up with that, and it could cause damage. And also, just like the other described scenario, you could have discharge air that's not conditioned fully like you want it. So that's the beauty of this setup. When both run together, you have that outdoor air gets conditioned by your return air, and then before it comes out to, before it gets distributed within your house, you have either your heating coil, if you're in heating, or cooling coil, to further condition that air and make sure, in cooling, your discharge air is going to be close to 55F, or in heating, you're going to be at 100 or 110F as it goes out. And so that's going to be working how you want. So to make that work, I emailed Fantech, and I will give them credit. Awesome response time. I emailed them at 10 p.m. and they got me a response by probably 8 a.m. the next morning. And so they gave me these 2 scenarios on how to have it interlock such that when the furnace fan turns on, the ERV turns on. And so this bottom option here, was connecting a relay to the power supply on your blower motor, but because I have a variable speed blower, that gets a little more complicated. I wasn't about to go splicing into my expensive new carrier furnace, so I didn't want to go with that option. And so the second option here was if they had auxiliary normally open contacts on the furnace that close when the fan comes on. So I didn't have that either, but my dad gave me a really good idea. There's a $10 sales switch you could buy on Amazon. I think it's made by the brand's called Suburban, and what that essentially is, it's a little metal rod that is on a little black plastic piece that has a circuit inside it, and when it's almost like a little feather, and when you turn on your furnace and that airflow hits it, it closes the circuit. And what I did was put one of those in my ductwork such that when the furnace blower came on, whether it be for recirc, for cooling, or for heating, that contact closes and the ERV also turns on, and then I have full control and always am ensured that both devices are on at the same time when I want them on, and not just one or just the other. So that worked out really well. And so the wiring is probably going to be specific per ERV, but for that example, for my for my Fantech ERV. That is, you wire that to the two H plus and H minus. This ERV has 3 different wiring harnesses you can use, and so that's what I did on one of those. So maybe it's a good idea if you had the same ERV. I also bought the, let's see, which one of these did I buy? I think I also bought this EDF7, where this is good for just testing and balancing it. It was only about 50 bucks. I think the guy was saying they got an EDF8 out now. And you can't hook up multiple different ways to control it at once, but I did use this to just prove like, okay, I could, and I was using the 2 W ports in this wiring harness. I did prove like, okay, I can put it in, low, medium, or high fan speed mode, and you could put it in, have it ventilate you for 20 minutes or things like that. So these devices are great if you got a standalone system, but I went with this way because I've got an integrated system. Yeah. And last but not least, here's some results using the Airwaves indoor air quality monitor. So you can see what I've got shown here is CO2, for example, where days where my fiance and I would both, stay at home all day, for example, the CO2 ppm would sometimes go up above 1,000, almost hitting 1,200 sometimes, which in this grand scheme of things still isn't awful, but was something I wanted to improve when we were both home, give us a little more fresher air, get the oxygen pumping, get those brain cells firing on all cylinders. Bussin', as the youth say. So you can see this was pre-ERV installation here, and on about 10.1 when I did install it, the CO2 average drastically improved if you were to take the average of this time versus this time. And you can also kind of tell, like when we would leave to go out, the CO2 took a long time to dilute and go down a little slower. It would take hours because the house is sealed pretty well. Whereas when you've got an ERV, that CO2 is almost dropping instantly. And you can see this is every time it's kicking on, you get those reductions. So that was pretty cool to see the results. And also you can see the improvement as far as, now some of this is tied to seasonal changes as well, but when you're showering, for example, when you've got all that humid air that kind of sticks around your house, that is definitely also reduced by having an ERV.
As they say on MTV Cribs, this is where the magic happens. So, checking out the ERV where we've got it installed here, kind of looks like Doc Ock in the basement, but it is just the ERV. I've got it mounted here on chains, and also on each one of the chains, I looped a screen door spring on those chains. So it's a poor man's anti-vibration install, because I first installed it to the wall using the supplied wall bracket. And because there are 2 fans in this bad boy, there's a fan on each side, your exhaust side and supply side. Those fans, when mounted to the studs, were really creating like a low frequency noise. It sounded like a helicopter was going off in my stairwell and upstairs when this thing ran. So when it's installed with these chains, the 4 chains, you get really good vibration isolation, and you don't run into that issue as much, actually at all. I can't hear this run over the sound of the furnace, which I'll show you guys in a second here. So you do have a drain port for the condensate. I've got my poor man's ghetto condensate bucket right now, because I don't know how much condensate this thing's actually going to make. And if it doesn't make a ton, I'm probably not going to take the time to run a condensate pump. But if it does, in the wintertime, start frosting up and melting a lot and creating a lot of condensate, I'll probably run a condensate pump to my drain, which is my floor drain's over on the other side of the basement. So that's why I'm kind of in the monitoring stage of that for now. So as I was showing you guys earlier on the diagram, I'll show you the 4 individual runs. So here's the return air run where it comes in. I did buy the Klein duct cutting tool that you can hook up to your drill that makes really nice circular cuts. So I made two holes in my return duct. This is the return air one, which pulls in the return air, comes down and goes into the ERV, and then you've got the exhaust air vent that comes out and runs to my exhaust louver on the wall, and that's got a backdraft damper on it, which is nice. I bought I'll show you guys the louvers. Those came from Fantech as well. And then we've got our outdoor air that comes in and goes into the ERV. And then that treated outdoor air comes out as supply air. And then that makes its way to the furnace return over here. And of course, then that fresh supply air is pulled down through your furnace blower and circulated out the supply side of the furnace and distributed throughout the house. So I've got the here is that sail switch I was describing to you guys earlier. That's in the duct and detects anytime the furnace blower comes on, and then that thermostat wire is ran all the way back to the control panel of the ERV. And like I mentioned earlier, here is that EDF7 controller. It's not currently plugged in right now. I only used it for testing because you can't have multiple control sources hooked up at once. So since I do have this hooked up with a sail switch, it is kind of unfortunate, but I can only run the fans at full speed because there's no way in the controls I can have it turn on using the H plus and minus and also somehow control fan speed at the same time. So you want to keep the ERV well balanced such that it can maintain its full efficiency when you have equal amount of air being brought in as you are exhausting. So that keeps your efficiency in that 60% range across all operating spectrums. And if you are bringing in either way too much supply or way too much outdoor air, or if you're exhausting far more than you're bringing in, you get that imbalance, your efficiency would drop, and also you could deal with home pressurization issues, like your house being negatively pressurized too much, which could lead to infiltration air being brought in from the outdoors, and that would affect your heating or cooling bill. Or you could be bringing in gases like radon or methane from underneath your soil, and positively pressurizing, they claim, could lead to possibly pushing moisture into your walls or things like that. I don't really know whether that's feasible or not, but definitely didn't want to run into that. So I've got just barely positively pressurized leading balance to my system, like probably only 5 or 10 CFM positively pressurized. Another thing you should watch out for, if you don't have high efficiency furnaces or water heaters in your natural draft, you definitely don't want to mess up the pressurization of your house. That could lead to backdrafting, which look that up, right? If you're not confident in your ability to balance this, definitely have this checked by a professional, because you do not want to be backdrafting your appliances, and potentially that could lead to CO poisoning. So let's go ahead and open up, check out the guts inside the ERV. There's a latch on the bottom of this, 2 latches, one on each side. So you can see here's where your 3 wiring harnesses are connected. Right now I've only got the H plus and minus connected, but at one point I did have the EDF7 control connected to its wiring harness. You've got my nice hand drawn diagram here of the 4 airflow sources, and they include this nice graph for you. You've got your core with the 2 filters and your handle, and then you just slide out that core when it comes time to clean it. And here's your two fans as well, one on each side. And then I just turned on my recirc fan for 15 minutes on the furnace to give you guys a audio clip of how loud the ERV is while it's running. So it's really not that loud at all. I don't know if the phone will pick it up here, but it's no louder than the furnace fan. If you walk away a few feet, you can barely hear it. So it is really quiet when it runs. And man, like I said, this thing is just awesome. You almost want to lay on the ground next to the vents and sniff the fresh air that's coming in. It's really a pretty cool device here. And then as far as the ducts I use, those are just from Home Depot, the silver jacket ducts. So you have, I think they're a little less permissible than the black jacket ducts. They're a little more money, but worth it. R6 insulation, so you don't have any condensation issues in the summertime or bringing in that cold air as well. Condensation on the inside or the outside of the ducts. And yeah, that I used Home Depot sells these like vinyl strap hangers. You can just hang with some sheet metal screws. In hindsight, I would have used some washers to give those screw heads a little more diameter, because sometimes that nylon, the screws would fall through it, which was really annoying while trying to hang the duct. So that's a hindsight pro tip that I wish I had thought of earlier. I'll go ahead and show you guys the quick. I also bought, Fantech had 5-inch connections that we can make with the outside wall that come in, and they've got sheet metal that run about 18 inches into that flex duct, which is nice. And then I sealed it up. I drilled 6-inch holes through the plywood with a 6-inch hole saw, because by the time you have a 5-inch duct and then the insulation of a flex duct, you're almost at 6 inches in diameter. Here we are, fall in Michigan, where the sun sets at about 4 p.m. Here's that exhaust louver where it's got those backdraft dampers, which are nice, so you don't get any wind gusts that work its way back into the ERV. And then here's where I've got the inlet louver, and these were nice because they both also, you can't tell in the dark, but they both also have little bird screens in there, so you can't have chipmunks or birds working their way into the house through your two louvers.